So in number 1A, we're given a list of ordered pairs. This is a mathematical relation. So 8 is related to 0, 5 is related to 4, etc. We're first asked to do the function mapping, or just the mapping in general. So we write the domain, in other words, the x values, in the oval to the left. So 8, 5, 9, and 3. And then we write the range, in other words, the possible y values in the oval on the right. 0, 4, 3, and 8. And then you need to have lines or arrows that connect. So 8 maps to 0, 5 maps to 4, 9 maps to 3, and 3 maps to 8. Any questions on the mapping? Okay. You can also express a relation graphically. So for this one, it's just going to be a set of dots. 1, 2, 3, 4, 5, 6, 7, 8. So 8, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4. 5, comma 4. 9, comma 1, 2, 3. And 3, comma 1, 2, 3, 4, 5, 6, 7, 8. That's it. The domain, it's just the set of all the x values. And we will use set notation, which uses a curly brace. It's preferred that you do not repeat anything and you write the numbers in order. If you were not to write the numbers in order, it's generally not that big of a deal. I care more about lack of repeats, because I think that's just unnecessary. The range is the set of all the y values. In other words, the set of all the outputs. Okay, so I'm getting those from these ovals or from the x's and the y's there. Is it a function? So look, do you have any x value that maps to more than one y value? You don't. So this is a function. You could also use the vertical line test. Looking at the graph, you cannot draw a vertical line that crosses through more than 2 points. Another hint is, do you have any repeated x values in the list? You don't. Any questions on 1A? Yes? 1B. So in our domain we have 9 and negative 3. I'm not going to repeat the 9. The 9 maps to what? Shout it out. Negative 2 and 2. So when you put a 9 into this machine, so to speak, it gives you out two numbers, negative 2 and 2. And then the 3 maps to a 5. The graph, I think you guys know how to do by now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, negative 2, and 9, positive 2. And then negative 3, 1, 2, 3, 4, 5. The domain consists of negative 3 and 9. Those are the possible inputs or x values. And the range consists of negative 2, 2, and 5. Is this a function? Shout it out. No, it is not a function. Multiple ways that you can determine that. You have repeated x's in the list of ordered pairs. From the mapping, you can see that a 9 maps to more than one y value or more than one element in the range. And you can use the vertical line test. You'll notice that you can draw a vertical line that crosses through more than once. So not a function. Any questions on B? Great. C, we have negative 12, negative 10, and 8 in the domain, and 3 and 5 in the range. Negative 12 maps to 5, negative 10 maps to 3, and 8 maps to 3. let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have enough, so I'll go in 2s. This will be -2, +2, and we might as well make this +2 and -2. So -2, -4, 6, 8, 10, 12. And then I need to go to 5. 2, 4, 5. Don't hesitate to rescale if you need to. -10. 1, 2, 3, 4, 5. And that goes to +3. And 8 goes to +5. 1, 2, 3, 4. Okay. Domain consists of -12, -10, and 8. The range consists of 3 and 5. Shout it out, is this a function? This is a function. Each element in the domain maps to only one element in the range. Yes, I know that -10 and 8 both map to 3, but that doesn't break the rule. It also passes the vertical line test. You can't draw a vertical line that crosses through more than once. So this is a function. Good. It seems like at least some of you have a good idea as to what a function is and how to figure it out. Okay?